Okay, in this third and final lecture on color theory and practice, we're going to be looking at working with pigments. There's a lot to be covered here. I'm not going to cover everything that needs to be known. I'm going to focus mostly on the whole concept of primary colors and the idea of color gamut as a way of explaining that. And then I'll finish by describing the three color exercises that you've been asked to do for the course. Okay, so to begin with, the notion of primary colors is something that's pretty strong in the history of color. We're all taught it in school, and there's a lot of ink written about it, and it can be very confusing. The idea of three colors making all the colors is an old idea, and there's a lot of validity to it in many ways. If we think of colored light, red, green, and blue, our TVs, our computer monitors, things like that, and there's certainly three primary colors through which all colors are made. Even printing, CMYK, and also our eye is designed that way with three different types of photoreceptors that are each sensitive to different areas of wavelength. However, it doesn't necessarily translate over into painting very well, or rather, if it does, there's really no need for it whatsoever. So bear with me and I'll describe what I mean. So we've seen so far that there really are two different types of color, and as a result, two different types of primary. So additive color is when you add light together. Again, this is the television, the computer, stage theater lighting. Whenever you take a piece of light and you add more to it and more to it, you get brighter and brighter. And you put these three primaries, red, green, and blue, together, you will get white. For artists who are dealing with pigments, we've seen, looking at the spectral reflectance curves, that pigments subtract light, meaning they don't reflect all of the wavelengths of light. So when you combine pigments, you're only really showing what they have in common. Everything else is being canceled out. And so we call that subtractive color. And you can see here the red, yellow, and blue, the traditional painter's primaries. And theoretically, when we mix them, there's the green, orange, and the purple. When you put them all together, you get something, in theory, that should be black, but in practice is more like brown. And if we look at the secondaries over here, we get cyan, magenta, and yellow, and you put them all together, you get white. So additive color is not something we're working with. We're working with subtractive color, but the problem with subtractive color is that these primaries are suspect. They're not really the best primaries. If you were going to choose three colors to try and make as many colors as possible, these are not really the three that you want. The answer to that, what are the correct three, is right here. They're known as CMY, cyan, magenta, and yellow. These three colors will give you a lot more range of colors, called a gamut of mixing, which I'll explain in a minute. This is used in printing, so your computer printer only has three colors, CMYK, K stands for black. And when they're transparent inks, the range of colors that they can make is pretty impressive, hence the images we can print off of our printers. Now, this knowledge of the primaries, the correct primaries, and how they're used has been around for easily over 100 years, but still it's not really taught in art schools. Art schools, for some reason, are just stuck on the idea of red, yellow, and blue, and part of that might have to do with industry. Magenta is not an easy color to find, but then again, there's obviously not the demand for it. Otherwise, there would be. And the same with cyan. We usually think of, well, our substitute for cyan is usually a phthalo blue, which is a kind of bluish green. Here it's kind of lighter because obviously it's mixed with white, or there's white coming through. This was a transparent color. So they are there. They're just on the market. You don't see a lot of magentas and cyans. You mostly see varieties of red and blues. So finding those three primaries sometimes can be a challenge for people. Now, this is Johannes Itten. He was a member of the Bauhaus School of Art and Design in Germany. Very influential school of art that kind of set a lot of the standards for art education. He was the color teacher, and he wrote some very influential books on color, and his ideas have kind of shaped art education in Europe and the United States ever since in terms of how we approach color. And what's interesting about Itten and his work is that his very first color wheel, which was a color star, back in 1921, actually had these three correct primaries. You see the cyan, you see the purple, which is a magenta, and you see the yellow, and these are equally spaced. So all the other colors, you see three on each side in between them. So these were the primary colors in his original teaching. And what's interesting is later on in his career, he started writing books, he developed this color wheel, which you will find in websites, art books all over the world, and notice that the cyan, magenta, and yellow has disappeared. So again, it's one of those curious things where artists just seem to be stuck on red, yellow, and blue. But we'll find out as we start talking about this that the whole idea of primaries itself is suspect and is really not something we need to take on board. And to explain that, I want to introduce the whole concept of a color gamut. So bear with me a little bit more. This looks very scientific, but it's not. It's the CIE chromaticity diagram. So these are all the colors that are produced by the different wavelengths of light. So we've got the blue down here, the green there, and the red there. And as they combine, they make all these different colors. This is used by scientists and color scientists to talk about colors and wavelengths and their relationship. Here they're all mixing to white, but you can have different variations of this. Now, a gamut is what we can see. So our eye cannot see all of this. Our eye can only see a limited range. But here we go to this triangle. This is what your computer can display. So we call that the color gamut. Anything outside of here, your computer cannot make with its pixels and its RGB. So you can see that the amount of colors on our screen compared to the amount of possible colors is very limited. And then if we take it one step further and we look at what our printer can do, we can see that this section here is what our printer is capable of. That's why when you print, it doesn't have, well, one of the reasons why it looks very different than on the screen. A, it's reflecting light rather than beams of light behind it, but two, it can't reach these sorts of yellowish greens or these sorts of deep, deep blues, and even some of these reds in the same way, so it's limited. All right, so this is an important concept to understand. What is a gamut? A gamut is the range of possible colors. Our eye has a gamut, our computer monitors have a gamut, the printers have a gamut, and this is useful when we talk about mixing pigments. So we took all the pigments and put them on a wheel. When we combine them, they get darker and they get duller. So subtractive color mixing could look a little bit more like this. The outside is the brightest, highest chroma, and as we go inside, we get duller towards gray. All right, so I'm going to use this wheel, but I'm going to take out the inside. I'll just keep the colors on the outside to make a point. So here's the colors on the outside. Here's the three traditional primaries, and they're usually ultramarine blue, cadmium red, not cadmium red light, and cadmium yellow. And this is where they place on the wheel and in terms of saturation. Okay, so cadmium yellow is on this ring of saturation. There's the cadmium red's a little more saturated. And then we come over here, ultramarine blue is a little less saturated. And so if we look at just this blue and this red, and we mix them together, the only colors we can get are the colors on this line. Okay, this is all the possible colors that we could make. If I go back to the other slide, it's like this. This is all the colors you can make right here. All right, all the blues and the purples and the reddish purples and the purplish reds. Okay. You cannot make a color here and you cannot make a color here. It's only between here. Likewise, this line is all the colors you can make between yellow and red, all these kind of oranges. And then these, but notice there's a bit of a curve here, and that's because largely the influence of yellow. So if you had three colors, this region right here, all the colors inside there are all your possible colors with those paints. Those paints can only make those colors. You cannot make this kind of green with cad yellow and ultramarine blue. It's not possible. So if we compare this to cyan, magenta, and yellow, this is what we get. So remember, cyan is often interchangeably used with phthalo blue. Instead of red, we use magenta, and for artists, the tube of paint, the pigment is, there's many types, but the most often is quinacridone magenta. And then the yellow is usually cad yellow light. Now look at the curves, and you can see that the space inside here is much bigger than the space inside the blue triangle. In other words, what do we gain? We gain lots more in the green region of the color wheel. All right, we gain a lot more in this purple region of the color wheel. We lose a little bit in the orange section. Okay, so we're losing some oranges. So that's what cyan, magenta, and yellow. It's a bigger gamut. In other words, if you only had 3 colors, these are the 3 you want. You don't want the other 3. Now, if we do our palette, which is the split primary, right? So we took both our yellows, both our reds, which is cad red light and alizarin, and both our blues, we get this orange gamut, and you can see it's even bigger than the CMYK. We're getting stronger oranges than the CMYK. We're getting a little bit more in the deeper blues, but we are losing again these kind of brighter purples because we don't have magenta. So this is, a bigger gamut. It gains here, but it loses here. So everything's kind of a compromise. But it just begs the whole question. Why would you limit yourself to 3 colors? If you want to have the minimum amount of colors, we have 6. Is there another way to use 6 colors and have an even bigger gamut? And the answer is yes. And that's by adding cadmium orange, cobalt violet, and permanent green light. So if we add these 3 colors and combine them with a selective red, yellow, and blue, if we combine it with cad yellow light, phthalo blue, and alizarin crimson, we get this black gamut, which is huge. It's a much, much bigger gamut of colors. So you might be wondering, well, if I had you buy 6 colors, why didn't I have you buy these 3 colors? And the answer is quite simply economics. These are 3 of the most expensive colors you can buy at an art store, and I didn't want to break the bank. I thought the split primary is pretty good, but if you're just going to have 6 colors, I would definitely do these. So if you want to build on your palette, if you want to have more colors, I would definitely start adding cobalt violet, permanent green, and cadmium orange when you can afford them. Because what you want are colors on the outside of the wheel. That's their highest chroma. You can always dull a color and go towards the middle. The middle is just dark, or dull. That's easy to do, but you cannot mix out. You cannot mix 2 colors and get lighter and brighter. I mean, you can't get brighter, more saturated. It only goes this direction. So it makes sense that your colors are as close to the outside of the wheel as possible. It gives you the most range. All right. So to sum it up, here's the traditional primaries, the colors that people use. Here are the modern primaries. Here's what we have, the split primaries. But if you really wanted to get rid of the concept of primaries and say, okay, what are 6 basic colors? These would be your 6. And notice there's no red. And you think, well, I thought red was a primary color. Well, you can make cadmium red or alizarin with these colors. So cad orange and quinacridone magenta will give you a good cadmium red light. All right. Then you throw in some cobalt violet and you're getting closer to her. So this is all possible with just these 6 colors. Okay. So now finally we're going to finish up with the color studies. You have 3 assignments, 3 different color studies. You're going to mix secondaries, complementary chords, and monochromatic and analogous chords. So I'll just go through them very quickly. So the secondaries, as you remember, are the mixes of the primaries. They're green, orange, and purple. And you'll notice that if we take green, for instance, your blue, like ultramarine, has 2 possible yellows it can mix with. And the phthalo also can be mixed with those 2 yellows. So in theory, with our 2 blues and our 2 yellows, we have 4 possible greens we can make. Now, obviously, there's many, many more depending on how much of which color you use and how dark and dull. But just with these raw pigments, what are the 4 qualities of green we can make, and those are the options. And so what you're going to do is something like this. You're going to create a box, any size you want, and then you're going to label it so that I know that this green, for instance, is this blue and this yellow. So these 2 are phthalo, these 2 are ultramarine, and then we go this way. We do columns. These are 2 are cadmium yellow light, these 2 are cadmium yellow. Now all this is explained on the videos in the project section, and there's a demonstration on how to do it, so definitely check that out. And what you're going to be doing is making something that looks like this, right? You have your 4 greens, your 4 oranges, and your 4 purples, all right? All I ask is that you keep it relatively neat so I can understand what you're doing, but that you label everything, all right? I need to know that you know what you're talking about when you mix the colors. And you'll see, here's our brightest, highest chroma green, because it's cad yellow light and phthalo blue, and here's our dullest. Now, it doesn't mean one's better than the other. It just means that if this is what you want, this is how you get it. If this is what you want, this is how you get it. All right? You've done all the purple exercise. Well, you did this purple exercise previously. You saw what you got was basically a dull brownish purple. But here we have our brighter purple. Okay, so that's the secondary studies. Now, when you darken a color, there are 3 ways to do it, 3 main ways to do it. You can add its opposite, its complement. You can add black or white, which is what most people go to. It's the default way of darkening and lightening. Or you can add analogous colors. All right. So what I want you to do is get rid of the idea of reaching for black and white every time you want to make a change of value. I want you to try complementary, and I want you to try analogous. So this assignment's going to have you mix those. All right, we'll start with complementary colors. Complementary are opposites, remember? So red and green, yellow and purple, blue and orange. So the easiest way to remember them is every primary is the other 2 primaries mixed, or just memorize. It's only 3 combinations. It's not that hard. Here they are again. So what you're going to do is this. You're going to create 7 boxes. You don't have to make a box. They could be circles, or you can just dab paint on it. But you're going to have 7 steps. You're going to have the complements on outside. So you're going to mix both reds together to make your red. And then you're going to take the highest chroma green, and you should know the answer to that, having done the secondary mixing. And then you're going to mix some red into the green and dull it, and more red and dull it, and more red. And likewise, this color here is red with a little bit of green and a little bit of green, and so on and so forth. So I also have a video in the assignment section explaining how to do this. So make sure you look at that, because it's very important. There is a way to do this properly and a way to do it improperly. And you'll have something that looks like this. This is our complementary chords. And you see you get all these wonderful, nice kind of neutral colors in the middle. So these are the colors you mix across the color wheel, so to speak. Monochromatic is the black and white. So here's our red. You add black, you add white, it goes pink. Analogous refers to colors that are next to each other on the color wheel. So these are analogous groups. That's one group, another group. Any 3 or 4 colors that are next to each other are considered analogous. And this is important because this is also a way of darkening and lightening. So if you have green and you want to darken it, you head towards blue. If you had green, you want to lighten it, you head towards yellow. So we're down here. So when you do this, you keep a lot of the color visible. When you do the other techniques, add black or add the opposite, you dull the color dramatically. So we want to also practice the analogous scheme, and this is what you're going to have. Each color, red, yellow, and blue, will have 2 rows. One of them is going to be monochromatic. One of them is going to be analogous. So in the monochromatic one, let's say in the red one, I want you to use cad red light, paint it in the middle. You're going to have 7 steps, and then add white on the left and add black gradually more and more on the right. And that's going to give us our monochromatic red. The next chord is going to be your analogous red. So you're going to go towards yellow this way, and you're going to go towards purple this way. Yeah. And you'll notice there's you can see the difference here. Let's say you need to darken your red and the object, you have a choice. Is this more purple or more brown? Do you want it duller or do you want it richer? Okay. Yellow really doesn't go much lighter than it is. Okay, so in this case, I want you to mix both yellows together because our lightness is only going to come from white. Then when you add black, look what happens. You get an interesting set of olive greens. And then when you come to the analogous mixing, I want you to darken it because yellow can go two directions. It can go towards orange and it can go towards green. Same thing with blue. Blue is the darkest color, so it's really hard to darken it, but try it. Put some black in there and then lighten it with white. And then for the analogous, to lighten blue, we head towards green, and to darken blue, we head towards purple. Probably a little hard to see in these slides, but when you do it yourself, you'll be able to see subtle differences between these darks and these darks. But again, there is a short video showing you how to paint this on the assignment description, so make sure you watch that before you attempt it.